I want to talk a little bit about permissions in cloud security. And this is because we cover all of these different data breaches all the time on the news stream. And I wanted to quickly go over, like, what does this actually look like on the back end? Because being someone who reports on this all the time and being someone who talks about cloud security, I wanted to know exactly how are these things misconfigured? How are people finding entire like buckets of data open and available that shouldn't be there? So last time we talked about IAM, or Identity and Access Management in AWS. And if we go over to my screen, we can see a different type of permissions. So Killian, you are much more adjacent to this sort of thing than I was. And I found out about a lot of this stuff relatively recently when I did a deeper dive on the way that kind of configurations can be messed up and data can be exposed. You and I talked about this a little bit earlier, and I kind of liked your definition. Do you remember what you said about the difference between IAM policies and then these sort of like bucket-based policies that we're going to cover today?
Yeah, the way that I like to think about it is like, so like on the bucket, you have policies assigned to a resource, and then you can control some level of access to that, like based on certain criteria. Now, let's like just assuming that the user we're talking about is like an internal user to the organization. They can have one or more policies coming from like the account or like as a member of a group that give them some type of rights, you know, to it can be a bucket, but it could be other things too. And then you have like an IAM policy. And the way I sort of think about it is kind of like a role. Role is the actual name of it, but it's something that you can sort of assume as like a user coming in to get some level of access or behavior assigned to it. So like if you're, you know, an external account, for example, and you need to connect to something, you can come in as that external account, assume the role that gives you access to a resource to do things. But in addition to all of this, you can configure like a bucket or resource policy to allow unauthenticated access as well on the resource. So you can put that star in the JSON, and you know, Amazon actually has some pretty good controls to prevent you from doing it accidentally, but like you can still do it. But it's you kind of user or resource based is the way I think about it. And I'm not. Hopefully somebody is watching this and can fact check me.
No, that all sounded good. I mean, because again, I'm fact checking you as a recent beginner as well, and that all sounds accurate. So if we go over to my screen, I have the IAM panel pulled up on my personal AWS account, which does nothing. It is purely for me to research on. So there's different things you can do with what we talked about last week, or whichever time was the last stream, which was talking about how we could create these user groups, and these users and user groups could be used to either temporarily or conditionally assign access to users to different resources, or to applications like virtual machines that are running and need to access like a data storage bin. That can all be managed from these policies. Now, there are some drawbacks though to using these policies, and sometimes people want to get more granular, and we can have something that we want to manage like an S3 bucket. And this is basically just a bucket to put all your data in. This could be all sorts of data, but it's basically, you know, something for you to put data in. It's a data storage bin. And the idea is other applications or users can programmatically access this. Or you could even do things like host a static site off of it by allowing public access, public read access to this. So policies can be either written as IAM or IAM. What's the right way to say it, Killian? You talk about this a lot more than I do.
IAM? Is that what you're saying?
Yeah, IAM. Okay, cool. Or it can be tied to the individual bucket. So if somebody's going to make a mistake, it's going to be in one of these JSON style. Well, it's not JSON style. It is JSON policies that makes a certain statement about who can do what with this resource. Now, these are pinned to the actual bucket itself. And what's cool about these is that they can be substantially longer. I think it's like 3 or 4 times longer than the same thing as a IAM policy. So if you have like a lot more granular permissions you want to do, or if you want to assign broad access to a resource like this, then you would write one of these JSON policies that basically takes care of that. So Killian, can you tell what this policy that I've applied to my AWS bucket does or is supposed to do?
All right. So the effect is, it looks like it's a deny statement. So what you're saying is restrict to TLS requests only. Effect deny. Okay, interesting. So and so it's on an S3 bucket. And then the resource is, okay, my Varonis condition. So the condition is secure transport is false. So I'm guessing just by the way this is written, it's saying if you try and connect without security, it's going to deny it. You're going to deny connection to the bucket. Is that what I'm reading?
Yeah, that's it. That's see. These are designed to be human readable, which I think is cool. So like in one of these policies, we have like the version, the statement, we have the SSID. So in this case, it's saying that it's restrict to TLS requests only. So it's giving us a clue to what this is doing. The effect is, like you said, to deny. Now this has an implicit deny. So unless otherwise specified, something will always automatically deny. So you can allow specific things, but an explicit deny that says like, effectively like this applies to everything. This will always come out on top. This will always override any allow if there's an explicit deny in place. So you can, so by default, you have an implicit deny that doesn't give anybody any permissions unless it's granted, and then you can apply permissions. But if one of these explicit denies hits it, then none of that matters because this is counted as the most important out of all. So then we have an action. So in this case, S3 star, that basically says any action that you can possibly take on this S3 bucket. And then we have a resource. In this case, this is my Varonis, and it goes so far as to give me, I think at the top of the page, like somewhere on here, what my particular resource information is. So then we have finally a bool that says if AWS secure transit is false. So in this case, that means if this is an HTTP and not an HTTPS request, then deny the connection. So by applying this policy to my bucket, then I basically say I'm going to deny all insecure traffic like through this bucket and make sure that like nothing is able to go through. So there's other ones that I think are kind of useful to know about that are involved in security and might be something where if they were wrong, a hacker could take advantage of this. So do I have edit access here? I don't. All right, I'll have to edit that. All right, so let's say I wanted to set a different policy. And let me set a different one. I'm going to save the changes. Whoa. Oh, it has an invalid resource. Oh, right. I didn't change it from the default. Okay. Well, I'm not going to apply this then. Instead, I'm just going to use this as our example. Can I hide this more? Ugh. All right. So, Killian, can you see, can you try to guess what this one is going to attempt to do?
So it looks like, just based on it, multi-factor authentication. So it looks like, and the action is delete object. So you can't delete an object. It will prevent you from deleting an object unless you have completed a multi-factor authentication challenge and response.
Exactly.
More or less
exactly. That's it. Yes. So this says, all right, I've identified a risky action, and I want to be able to prevent somebody from deleting it unless they have signed in with two-factor authentication.
Right.
So these are the kinds of security policies that are used to lock down these buckets, and a lot of them come kind of cookie cutter and default from like Amazon itself. So there's a lot of these templates that can be applied. So if you're looking to get into cloud security, two of the fundamental things you need to know about are these specific policies that are applied to a bucket or a resource, and then these more general IAM policies, which are applied to multiple resources. They can be applied to a bucket, but they don't allow for as much information to be put into the policy. So if you want to get more granular, or if you want to apply kind of broad access to a bucket, like again, like a static website or something like that, then you can certainly do that with a bucket-based policy. So these are the two most popular methods through which cloud resources are secured on the inside. When you're creating one of these resources, these policies kind of govern that. So if you're curious about cloud security, if you want to get more serious about learning how maybe these might be misconfigured or how you could detect misconfigurations, then this is a great place to start. And creating your own AWS account, creating a bucket, making some policies, and then attempting to access the files you upload and seeing what happens. This is all a really great way to try out some of these JSON statements which govern who can access which resources and trying it out for yourself.